Today we're going to tackle this problem about what is a pH when you mix a weak acid with a strong base. So first of all, we will want to write out the chemical equation to make our ice table. So sodium is a spectator ion, we're leaving that out. And it reacts to completion because hydroxide will make it react completely. And there will be some water neutralized. Okay, so we're given these information on the top here, and what we can do with this is turn it into moles. Now we know that concentration is mole divided by volume, so concentration times volume is moles. And then if I input this into my calculator, and with this, I'll enter it as liters. That will give us a concentration of 2.5 times 10 to negative 3 moles. While here, if I use this for liters, this will give us this many moles. So because it's going to react to completion, that means all of the hydroxide that we added into this mixture is going to react to completion since it's a limiting reagent. It's going to react completely with our weak acid here. So the amount remaining at equilibrium here is 0. And for here, on the left, it's going to be 1.43 times 10 to the negative 3 moles. Water is liquid, we can leave that out. And carbonate, because this is minus this number, carbonate will gain by that number. So what we end up finding here is we want the pH. And there are several ways to find a pH. But in this situation, the only things that we have in this system are buffers. So there is a conjugate acid and a conjugate base. And they're both weak. So this is a buffer. So the easy way to get the pH for a buffer would be to use the Henderson-Hasselbalch equation, which is pH is equal to pKa, and pKa is equal to a negative log of the Ka plus the log of the conjugate base concentration and the conjugate acid concentration, but since they are in the same volume, these will cancel out, and only the Henderson-Hasselbalch equation can you cancel out the volume. If you're using other equations, don't leave out the volume, because if you mix these two together, the total volume would be 50 millimeters plus 10 millimeters. So that's going to be around 60.7 millimeters. Okay, so if you're actually looking for the concentration for other equations, this would be the total volume you use. So in other words, for what I'm going to put here is the concentration of the conjugate base. So it's going to be this mole divided by this ml, but make it into liters, or because we can just leave out the volume in this case because it'll cancel out. But if you wanted to add the volume in, that would be how you do it. Definitely watch out for this, because some other questions, they will see if you remember to add the final volume. And this is the conjugate acids moles. So the thing is, which pKa do we choose? Because our carbonate here, carbonate, is actually a polyprotic acid where there's other forms. So there's going to be a Ka1 and a Ka2. So because our conjugate bases are these, we're going to use the Ka value number 2, whatever that be on your formula sheet. On mine it says this. So if we throw all of this in, we will end up getting a pH of 10.2. And there you have it.